We'll be covering 15.2 derivatives of exponential functions. In 15.1 we covered what happens when you differentiate a trigonometric function. For example, when you differentiate sine x, you get cosine x. Cosine x, you get negative of sine x. So today we'll learn how to differentiate e to the power of x. When you differentiate e to the power of x, the result is that you still get back e to the power of x. Yep, you heard that right. When you differentiate e to the power of x, you get back e to the power of x. Later on, there'll be some things a bit more complex, but for now, this is the knowledge that we have. Let's just move with it. Okay, so for example 5, okay, what we do here is this. If you notice, for 5a, when you differentiate this, what we're actually running up here is that we actually have u times v. So if u is equals to x squared, differentiating u with respect to x is 2x. V is e to the power of x. As we have learned in the previous slide, differentiating e to the power of x will give you e to the power of x itself. So now, okay, what happens here will be this. We apply we differentiate with respect to x squared e to the power of x. So we get v du dx, so it's v du dx, so we get 2x e to the power of x plus u dv dx, so we get x squared e to the power of x. And that's it, okay, for us differentiating 5 part A. 5 part B, similarly, u over v, what we're actually applying here will be the quotient rule itself. So if u is e to the power of x, differentiating u with respect to x is still e to the power of x. V is x plus 1, differentiating v with respect to x, you get 1. Hence, the application here, if I am differentiating with respect to x, e to the power of x, x plus 1, what I have is v times du dx plus u times dv dx, which is 1. Sorry, not plus, it's minus u dv dx divided by v squared, which is x plus 1 squared. So if I simplify, okay, if you want, you can actually what I call factorize e to the power of x from the numerator. What I'm left with is x plus 1 minus 1 divided by x plus 1 squared. So if I simplify, what I'll get is e to the power of x times x divided by x plus 1 squared. And that is part B. We move on to part C. So for part C itself, what they would like us to do is to differentiate with respect to x, e to the power of x plus 2 to the power of 3. So same thing, we will apply chain rule. So 3 e to the power of x plus 2, 3 minus 1 for the power gives you 2. Now differentiating what's inside the bracket, we are left with e to the power of x. So what we are left with is 3 times e to the power of x times e to the power of x plus 2 squared. And that's it for example 5. Now, do pause the video itself and try 5. And once you're done, you can unpause the video and we'll carry on in 3, 2, 1. Okay, this is it for try 5. So for part A itself, we are actually applying the product rule. So once again, u is x plus 1, differentiating u with respect to x is 1, v is e to the power of x, differentiating v with respect to x is e to the power of x. So if I apply the product rule over here, my final result is e to the power of x times x plus 2. You will actually factorize e to the power of x from this. For part B itself, it is similar. What happens here is this. We have the form of u over v. So this is application of the quotient rule itself. So if it's u is equals to 2 e to the power of x. So if you differentiate u with respect to x, you get back 2 times e to the power of x. V is x, dv dx is equals to 1. So if we apply v du dx minus u dv dx over v square, you factorize e to the power of x with the numerator and simplify, you're left with this for part B. In part C itself, what happens is we apply chain rule. So the 2 comes down, okay, 2 times e to the power of x, power minus 1. You differentiate what's inside the bracket, you're left with e to the power of x. So if you simplify, 2 times e to the power of x, we just put it up in the front here, times e to the power of x minus 1. And this is it for try 5. Now, okay, what we're going to do is we give you the formula. What happens if it's not just e to the power of x? What happens if it's something else? For example, what happens if we have e to the power of 3x? So, if I differentiate e to the power of 3x, what happens is I will differentiate the power. So 3x differentiated gives me 3. So I'll multiply everything by 3. Then I copy down e to the power of 3x. Okay, I give you another example. If I have, I want to differentiate e to the power of x, e to the power of, let's say, negative 4x. So if I differentiate here, differentiating negative 4x gives me negative 4, which I multiply, I just copy out everything, for negative 4 times e to the power of negative 4x. Similar idea, okay, behind this, what I call note here for this case. So for example, if I have e to the power of 3x plus 1, if I attempt to differentiate e to the power of 3x plus 1, 3x plus 1 differentiated will give me 3. So I put it out in front, this gives me e to the power of 3x plus 1. That is it. Okay, so just differentiate the power, then bring it down, you multiply everything by that power. Okay, so now very quickly, let me just do all of this. So given in part A, y is equal to 3 times e to the power of 3x minus 1, differentiating y with respect to x. Differentiating 3x minus 1 gives me 3. So 3 times 3 will give me 9. So what I have here is 9 times e to the power of 3x minus 1. Now for part B itself, the function in x is x cubed e to the power of 1 minus x. This is slightly more complicated, but it's just the simpler application of the product rule itself. Hence, if u is equals to x cubed, differentiating u with respect to x is 3x squared. If v is e to the power of 1 minus x, differentiating v with respect to x, 1 minus x differentiated gives you negative 1. So what I have is negative e to the power of 1 minus x. Now, if I were to apply the product rule itself, v times du dx, which is 3x squared, so let me just move this here, so it's 3x squared, plus u, x cubed, times dv dx. So here, what I'll have, I just erase out the positive, it becomes positive negative, it is negative x cubed e to the power of 1 minus x. If you actually feel like what I call factorizing e to the power of 1 minus x, what I'm left with is 3x squared minus x cubed. If you would like to further factorize x squared, so what I get here is x squared e to the power of 1 minus x, 3 minus x. Okay, that's it for part B. Now, part C itself, part C gives me the function g. Okay, the square root itself will be half, power half. So here, so my function g will give me e to the power of half theta. Now, if I were to differentiate with respect to theta, what happens is half theta differentiated with respect to theta gives you half. So I just bring it up in front, e to the power of half theta. Now, something slightly more complicated. If I have a function h, with respect to t, I get t cubed minus 1 over 3e t squared. So what happens here is this, very similarly, is u over v. So u is t cubed minus 1. Differentiating u with respect to t is 3t squared. If v is 3e to the power of t squared, so differentiating v with respect to t, okay, what we will get is differentiating t squared gives me 2t, so 2t multiplied to 3 will give me 6t. So what we have here is 6t times e to the power of t squared. Now if I were to apply my quotient rule, v times du dx, which is 3t squared. Okay, be very careful here. This is 3 multiplied to t squared, and this is e to the power of t squared. So you cannot take this t squared and this t squared to give you t to the power of 4. This is the index of e, while this is 3 multiplied to t squared. So be very careful with that. So v du dx minus u, okay, don't forget the brackets here, times dv dt over v squared. So v squared is 3et squared squared. Okay, now if I would want to actually try to save myself some trouble, 3 to the power of et squared, here also there's a 6, it can be 3 times 2. I can actually factorize 3e to the power of t squared. So what I'll do here is this, I'll write 3e to the power of t squared. In the numerator, I'm left with 3t squared from here, minus t cubed minus 1 times, I factorize 3e to the power of t squared, so there's 2t here, over 3e t squared squared. So what happens here is this, let me just try to shrink everything, I'm running out of space. E to the power of t squared, you will eliminate with one of this. So what I'm left with now is 3t squared minus 2 times t to the power of 4 plus 2t divided by 3e to the power of t squared. Then from my numerator, I notice I can still factorize a single t. So I get t, 3t minus 2t cubed plus 2 over 3e to the power of t squared. And this is it for example 6d. Now I'll carry on with 6e. For example 6e, if I differentiate y with respect to x, very simply, I just need to differentiate the power itself. So the power is x squared minus 1. So differentiating that, I get 2x minus 1, and copy down to e to the power of x squared minus 1. Similarly for f, for part f, the function f with respect to t is e sine t squared. So if I differentiate it f with respect to t, so sine t squared, if I were to differentiate with respect to t, sine t squared, what I get is sine t squared will give me cosine of t squared. Don't forget to differentiate this t squared here to give me 2t. So what happens here will be 2t times cosine of t squared multiplied to e sine of t squared. And that is it for part f itself. Okay, let's just push on, okay, to try 6. Do pause the video, and once you're ready, unpause the video and I will give you the answers for try 6. Okay, for try 6, for first one, Okay, if you differentiate with respect to x, e to the power of 2x plus 1, you differentiate the power, you're left with 2, you bring the 2 to the front, you just copy out e to the power of 2x plus 1. Similarly, for part B, e to the power of square root x, so e to the power of square, you just differentiate x to the power of half, you differentiate this, what you get is half x minus half, which is equals to 1 over 2 square root x, which they have written here. You multiply to the original e to the power of square root x, and you get this for part B. Part C is an application of the product rule. Let me write all of it down for you. If u is e to the power negative x, du dx is negative e to the power negative x. If v is equals to cosine x, dv dx is equals to negative sine of x. So what happens is this: you apply the product rule, v times du dx, okay, which you get over here times over here, and you take u times dv dx, which is over here. You can factorize e to the power negative x. What you get is this. Okay, that is it for try it 6. Okay, now example 7. This is a rather long example, but let's just push on and finish this. So the equation of a curve is given by x squared multiplied to e to the power negative x. Find expressions for dy dx and the second differential d2y dx2. Okay, so now first and foremost, for the first differential, u is equals to x squared, v is equals to e to the power negative x. Then differentiating u with respect to x, I get 2x. Differentiating v with respect to x, you get negative e to the power of negative x. Hence, differentiating y with respect to x, v times du dx. So it's 2x e to the power negative x plus u dv dx, x squared times this. So it should be a plus, but plus and minus gives you a negative there. So I get negative x squared e to the power of negative x. So what happens here is, if you would like, you can actually factorize e to the power of negative x. Then what I'm left with is 2x minus x squared. Now, if I were to carry on to get my second differential, u, okay, let me use a different color. U is e to the power negative x. Differentiating u with respect to x is negative e to the power negative x. V, 2x minus x squared. So the v dx will give me 2 minus 2x. Hence, to get my second differential, what I'll have here is v times du dx. So v times du dx. So I get 2x minus x squared plus u times dv dx, 2 minus 2x. Once again, if you notice, the common factor is e to the power of negative x. So factorizing e to the power of negative x, what's left inside my brackets is negative 2x plus x squared plus 2 minus 2x. So if you simplify, what you get will be x squared minus 4x plus 2 inside my brackets. Okay, so I found the first differential and my second differential as well. So now if I go on to part 2, I would like to determine the nature of each stationary point of the curve. So now for a stationary point, dy dx is equals to 0. So what I get here will be, from my previous slide, I have this for my dy dx. So let me just space it out. This is equals to 0 itself. So what we have here is, there are a few things that we can do here. So if you say that e to the power negative x cannot be equals to 0, So what I'm left with is 2x minus x squared equals to 0, x, 2 minus x equals 0, x is 0, or x is equals to 2. Okay, so that is my value. Now, if you remember my second differential, okay, which is over here, okay, let me just copy it out. Okay, let me use a different color. My second differential. Okay, now if you sub in my x equals to 0, what happens for my second differential is that the value that you will find using calculator will be greater than 0. So this is a minimum point. Similarly, when I use my second differential, okay, my x value is equals to 2. It will be lesser than 0. This is a maximum point itself. So now, okay, what you need to do is also to find the y values itself. So when x equals to 0, the y value is equals to 0 times e to the power of negative x. So it's 0 times e to the power of negative 0. The y value is 0. When my x value is equals to 2, my y value is 2 square is 4, and e to the power of negative 2 equals to 4 over e squared. So I can make my statements here. So for 0, 0 is a minimum point. Similarly, 2, 4 over e squared is a maximum point. And this is it.